This time we talk about the polymorphism, interface, abstract class, and method. Polymorphism. What is polymorphism? Polymorphism enables us to program in general rather than program in the specific. In particular, polymorphism enables us to write apps that process objects that share the same base class in the class hierarchy as if they were all objects of the base class. With polymorphism, the same message sent to a variety of objects has many forms of results. Means we create something in common for different subcategories. And when we can use the base class to refer to the derived classes, because one class can be inherited to different classes. The base class is something in common in the subclasses. And we can use the base class to refer to different derived classes. If the derived classes all implement their own version of a method which is inherited from the base class, then we can use the base class object to refer to the same methods, but the methods are implemented differently in different derived class. Then different behavior will be acted. This is kind of a polymorphism, and we're going to show you the example that how it works. Means we're going to use base class to refer to the derived class with the method declared in base class, but it is implemented again in the derived class. And that's the meaning of program in a general rather than program in the specific. With polymorphism, we can design and implement systems that are easily extensible. New classes can be added with little or no modification to the general portion of apps. As long as the new classes are part of the inheritance hierarchy that the app processes generally, the only part of the app that must be altered to accommodate new classes are those that require direct knowledge of new classes that you add to the hierarchy. And there's a keyword we can use called abstract. We declare a common set of functionality for all classes in the updated hierarchy in an abstract class. And you're going to see the example quickly that you understand it better. Another important thing we talk about in this chapter is interface. Interface describes a set of methods and portions that can be called in an object, but does not provide a concrete implementation for them. You can declare classes that implement one or more interfaces. Each interface member must be defined for all classes that implement the interface. Once a class implements an interface, all objects of that class is a relationship with the interface type. All types of class that are guaranteed to provide functionalities described by the interface. This is true of all derived classes that are the class as well. Interfaces are particularly useful for assigning common functionality to possibly unrelated classes. This allows objects of unrelated classes to be processed polymorphically. Objects of classes that implement the same interface can respond to the same method calls. And that's the idea about the interface. And we'll also talk about operator overloading in this chapter. Now let's look at the first example, polymorphism. And in this project, there are 3 files. The first one is employee.cs. The second one is base plus commission employee.cs. And the third one is test. Let's look at the employee. And these are the private members. This is the constructor. And these are the properties: first name, last name, social number, gross sale, commission rate, earning, toString. Notice here earning has a keyword virtual, means the code will be written in the derived class. Let's look at a base plus employee. It inherits commission employee. It adds 1 data member, base salary. This is the constructor. And this is the property, base salary. And this earning override. It overrides the method of earnings from the base class employee. And this overrides toString. And this is pretty much the base plus commission employee. Let's look at a test. This is the test. And after you run the test, you see the result like this. So let's look at the code here again. Object commission employee. The type is commission employee. The second one, base plus commission employee. And the console displays the message for employee and the base plus employee. So there's the information here, second object information. Now let's look at the last part here. This part is very interesting. We're doing polymorphism. Now look at this. Commission employee. This is the object of commission employee. The type is commission employee. Equals base plus commission employee. And this is the object of base plus commission employee. Remember, base plus commission employee is the derived class of commission employee. So this time, the object commission employee get base plus commission employee. See, giving the base plus commission employee to commission employee 2. And this is the polymorphism. So at this moment, commission employee 2 is type of commission employee. And what if this time you call toString and earning? toString is the method of commission employee. Earning is the method of commission employee. Let's look at a commission employee. This is the earning. Return commission multiply gross pay. And this is the toString. First name, last name, social number, commission rate. In base plus, the method is overridden base earning plus base salary. And the same thing, the toString is overridden like this. So in test, when toString toEarning is called, but remember this is a commission employee 2, but the object is assigned base plus commission employee. So which toString and toEarning is called means it's the toString earning of commission employee or base plus commission employee. If you look at the result here, you can see that 500, 300, this is the same as this one here, means the commission, means the base plus commission employee is called. Base plus, a base plus commission employee is called, means the derived class toString toEarning is called. And this is the polymorphism. That means commission employee 2 is type of commission employee, but the object base plus employee is assigned to commission employee. So at this moment, commission employee is actually type of base plus commission employee. That's why toString and earning versions are from base plus commission employee. So from this example, you can see that we can assign a derived class object to a base class object. Then the base class object becomes the derived class object. And that's why it can call toString and earning, which is the derived class version. But notice there, since this is the derived class, we use base class to call derived class method. And this is possible because the base class is type of, the derived class is type of a base class. But one thing you need to be careful that you can only call derived class method if the method is declared in the base class. If there's a method declared in derived class which is not declared in base class, then you cannot call the derived class method through base class object. And that's the point. For example, you notice there in base plus commission employee, there is a property called base salary. This is only available in base plus commission employee. And if we want to call base class salary, you see that from the list it's not available. Anything we see here is declared in the base class commission employee. And the methods extended to base plus commission employee. But if there's any methods declared in base plus commission employee only, then they're not available here to call. So right here, I put a note here saying base salary. Right here is not available. So right here, if I try, I say base. You see, I get an error right away. This is not right because it's not available. So that's not okay. I'm commenting this out. And that's the polymorphism. With polymorphism, we use base class to refer to the derived class, and we can call the methods from derived class As long as these methods are declared in base class, then we can call it. And the C# .NET framework is smart enough to know what code to be executed. That's the polymorphism. The question is, why do we do this? Polymorphism provides flexibility in the programming because we may have different derived classes, and probably we want to manage those derived classes objects through the base class, and we may have several objects at the same time of derived class. Then we can all use the base class to refer to them. We sometimes we do need it. It provides the flexibility, and we want compiler to figure out which version to pick it up. And that's the power of OOP, object-oriented computer programming.